In this episode of Single Variable Madness, we're going to solve for the real solutions of this equation, if any. We know that there are going to be 3 solutions for this equation because this equation is of degree 3, but we don't know if they're all complex roots, real roots, or some combination of the two. So the first thing we can do here is maybe try factoring. We can try factoring an x squared out of here and maybe a minus 3 out of here and combine it somehow, but that won't really get you anywhere because that would just factor it into some groups, but that won't give you any more information. We could try to use the cubic formula, but that's a really huge formula. If you search up on Google cubic formula, you're going to have a huge equation that you have to plug in these values for, and that's not really a sporting idea. So we have to be a little creative when solving this. The first thing I noticed is this 3x squared, this 3x, and this 1. They look a little familiar in that if you look at Pascal's triangle, it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Pascal's triangle tells you a lot of things, but one thing it's really important for is that it shows you the coefficients for binomial expansions. As you can see over here, look at these coefficients. You got 1 over here, -3, -3, and -1. It looks almost very similar to this, 1, 3, 3, and 1. However, these are negative coefficients over here. So we kind of want to make them positive, and maybe we can act on that later. So we can try taking these 3 terms to the right-hand side. So we get x cubed, we're going to leave this over here, equals 3x squared plus 3x plus 1. So it looks more familiar now. You got the 3, the 3, and the 1. The 3 and 3 and the 1. But we still need the x cubed term on this right-hand side. We can't subtract this on the right-hand side because then it will make the coefficient negative. So what we can do is add x cubed on both sides. So add x cubed here and here, you get 2x cubed. And then you get x cubed plus 3x squared plus 3x plus 1. And now we can factor the right-hand side. This right-hand side can be factored into x plus 1 cubed. Now you can go through the foiling process and get from here to here, but I'm going to spare the time for that because you can use Pascal's triangle to do that. As you can see over here, Pascal's triangle tells you that if you take x and 1 and cube it to the 3rd power, then the terms you're going to get are going to have coefficients of 1, 3, 3, and 1. Same thing if you square it. If you square x plus 1 squared, you're going to get x squared plus 2x plus 1. 1, 2, 1. So this Pascal's triangle tells you the coefficients depending on what you raise it by. But anyway, now that we can factor it like this, we can still have 2x cubed on this side. Let's just cube root both of these. So we get the cube root of 2 times x, cube root times x equals x plus 1. Now subtract x on the other side, get x, and then you can factor out an x, of course, times the cube root of 2 minus 1 equals 1. X equals 1 divided by the cube root of 2 minus 1. And that is our answer. And of course you can rationalize the denominator if you'd like, but I'm not going to do that.